皆さん、こんにちは。私はアンドレアと申します。My name is Andrea, and I'm a fifth year in the IGP program studying both computer science and Japanese. For those of you who don't know, last year I went to Japan and I studied abroad at Kansai University in Osaka. So I would like to start by talking a little bit about my time in Japan. I started taking classes there in September, mostly staying around Osaka and the Kansai region, and I received an internship at the university around the end of December. However, after talking with my mentor, at my request, I was able to delay the start date of that internship until around late March to early April when the spring semester was supposed to begin. And this was so that I could take the 2 to 3 month winter break to travel around outside of Osaka before I turned my focus towards school again. My mentor was super supportive and he encouraged me to really experience as much Japanese culture as possible while I was abroad, so I was able to visit a lot of different places. I actually started by flying to South Korea, where I visited some family members and mostly stayed around Seoul. After that, I flew to Fukuoka, which is near the south end of the country. And from there, I sort of went northeast until I hit Tokyo. And I made a lot of stops like in Hiroshima, Miyajima, Himeji, Kyoto, and some other places as well. In particular, I visited several shrines and temples, which was one of my favorite things to do while I was in Japan. I could go on about it, but in the interest of time, I will say that one thing that was really cool was that I got to see a special ceremony at a Buddhist temple in Nara called Shunie, where the monks carry these giant torches and they run along the balcony as part of this sort of cleansing ritual that they do once a year. And this is really notable because those structures are essentially made entirely out of wood. It was too dark for me to take any photos personally, but this picture on the bottom right shows what that's supposed to look like. And it was a really neat experience. Then in Hiroshima, I was able to visit the Peace Memorial Museum, which is dedicated to teaching people about the World War II nuclear bombings. Um, I wouldn't strictly say that I enjoyed it because it's honestly a morbid topic, but at the same time, it was a really eye opening experience, and it's easily something that I'll remember for the rest of my life. It gives such a different perspective on the bombings that we don't get in the US, even if on some level we know it was bad. So the importance of it and understanding that history and the trauma that it caused really stuck with me. It was something that I hadn't had the time to do while classes were in session, so I'm really grateful that I was able to do that while I was on break. With all of that said, as I'm sure some of you may have put together, this decision to travel for a couple months meant that my intended start date landed during the peak of the coronavirus pandemic. In fact, I was forced to return to the US at the end of March, which just so happened to be the very week that I was supposed to start going to my lab. Of course, it was really disappointing to miss out on this opportunity while I was abroad, but I did gain a lot of invaluable experience and memories in the months leading up to it, and also in the face of this sort of unprecedented situation. And as a silver lining, I was also able to pursue an independent research project for my fieldwork experience concerning a topic of my own choosing and one that I have a lot of personal interest in, which is why moving forward, I'll be talking about that topic, and that is Japan and natural language processing. So, to just really briefly explain what natural language processing, or NLP for short, is, it's a subset of artificial intelligence which looks at the interaction between computers and human languages. And essentially, it's just about trying to get machines to understand human language. So, machine translation, for instance, is one very clear cut example of where this is useful. There's a lot of interest in it globally, of course, but Japan in particular has a lot of reason to research these sorts of technologies. In recent years, they've had a lot of interest in bolstering tourism and even gradually promoting more immigration in order to boost their economy. And although English is a mandatory subject in schools, the average Japanese person can't speak much English. So, as a nation, Japan is fairly monolingual for the most part. And to add to that, Japanese is not spoken much outside of Japan either. So, Machine translation programs would pose one solution to language barriers, and in that sense, they could help encourage people to visit and explore the country. A more subtle example of NLP, though, would be something like textual analysis, where a machine is programmed to parse through text and to somehow understand the content and provide some other functionality based on that. For instance, because Japan is so prone to natural disasters such as earthquakes, tsunamis, and typhoons, there has been research into mining information from social media platforms like Twitter in order to organize data like missing persons and supply shortages, and to communicate important safety information. It's also very useful in the healthcare industry. Because of Japan's aging population, there's a lot of concern over caring for elderly citizens in the face of a shrinking working class, which has led to a growing interest in using technology to potentially lighten the load of healthcare professionals. And this is often why you may see news about things like Japanese researchers developing robots to act as nurses. In the case of NLP, though, there are a lot of relatively simple tasks that you can automate by using text analysis. This program here, for example, is a concept for extracting and standardizing patient complaints in order to monitor adverse drug events. So the machine would use NLP to try and understand what is written, and after analyzing the data, it would identify an appropriate ICD-10 code, which stands for International Classification of Diseases, and it would try to apply those to the patient complaints. And by doing that, the goal would be to not only ease the workload of healthcare professionals, but also to potentially solve communication difficulties. Of course, in order to address miscommunication, the system has to be fairly robust in understanding human language, which is often a difficult target to reach in this field. I'm actually going to interrupt myself here, though. As you can see, my research does deal very heavily with Japanese language and linguistics, so I thought I would discuss those first before moving on. For those of you who may not know much about the Japanese language, here are a few interesting features. Most infamously, perhaps, they use 3 different writing systems called hiragana, katakana, and kanji. The first 2 are pretty standard alphabets, while kanji refers to the use of Chinese characters which are not phonetic, meaning that you can't tell how it's pronounced just by looking at it. In fact, there are often multiple ways to pronounce the same kanji. Usually there are at least 2 pronunciations for any given character, but there can be as many as 5 ways, and you just have to develop some intuition for it. A lot of words, especially verbs, are written using some combination of kanji and hiragana, so even within one sentence, you usually see more than one writing system. To add to that, Japanese words often have a lot of variation where there are multiple ways to write the same thing. So for instance, the word sakura, which means cherry blossom, can be written either using a single kanji or phonetically in either hiragana or katakana, and they technically are all correct. Then Japanese is also what's called an unsegmented language, meaning that they don't use spaces to separate words. Again, this is something that you just develop some intuition for, but it can be confusing if you don't know how to separate the words, so to speak. Also, as a result of this, Japanese writing is very condensed compared to English. So for instance, if you're tweeting in Japanese, you can actually say more within the character limit than you can if you're using English. Regarding my own experience with the language, though, I've studied it for around 6 years now, including, of course, the time that I spent abroad and where I took a couple of Japanese language classes at the university. I also had the opportunity to take a couple linguistic focus courses in Japan, such as a sociolinguistics course and a class called Comparative Analysis of Japanese and English, which gave me a lot of insight into this topic. From a purely linguistic standpoint, I learned quite a bit about morphology, which refers to how we break down words. This is one of the first steps in NLP called morphological analysis, and it usually refers to the preliminary task of identifying words and the basic units that make up those words. In my research, I focused particularly on this step, trying to see how it was unique to the Japanese language in both problem and solution. So as I mentioned, Japanese is unsegmented. So usually don't have spaces to explicitly show where one word ends and another begins. Techniques to address this have been studied very thoroughly, but oftentimes when a morphological analyzer is giving a really strange output, this is the cause of it. And I'll give an example of this in the next slide. It's especially common when the machine sees a word that it doesn't recognize. Some other issues are named entity recognition, such as recognizing location or product names instead of trying to just look them up in a dictionary, which would be the incorrect approach. And since words are shorter and Japanese doesn't use capitalization, this is usually more difficult to do than in English. There are also a lot of multi-word expressions in Japanese that function more as a single unit, but because they're technically made up of different words, they take on a lot of grammatical forms, meaning that the machine has to recognize these words collectively, but because they have so much variation, it can't store them as their own dictionary entries, so to speak. But here's an example of how morphological analysis can go wrong, particularly in Japanese. This is what's called a segmentation lattice, and basically it shows all of the different possible ways that you can interpret this phrase that is supposed to be read as Gaikokujin Sanseiken, which means foreigners' right to vote. So these boxes all represent the ways that you could try to separate the words. The correct segmentation is Gaikoku, foreign, Jin, person, then Sansei, voting, Ken, right. And that's how you get foreigners' right to vote. However, it's entirely possible to incorrectly segment this into foreign, gaikoku, then ninjin, carrot, and then seiken, regime, which put together would be foreign carrot regime. And what I'm trying to highlight is the huge discrepancy in meaning, where in Japanese you can have this normal phrase that via incorrect segmentation can somewhat easily be misinterpreted as something completely nonsensical. A good morphological analyzer would actually realize that this second interpretation is absurd, and it would probably throw out the result and try to figure out something more sensible. But it turns out that a lot of Japanese morphological analyzers use this approach with a segmentation lattice. Often what they do is combine linguistic technique with machine learning algorithms in order to segment the sentence in such a way that they can effectively perform tasks like parts of speech tagging. So one method is to use what's called a conditional random field and train it over segmentation lattices so that it can start to predict correct sequences. Alternatively, it's possible to use a recurrent neural network language model, which is a model that is trained on a bunch of sentences in order to recognize semantically appropriate word sequence. This allows it to output a probability distribution of what the next word in a sequence might be, and to penalize strange segmentations like the one I previously mentioned. So both of these techniques are hybrid models that combine linguistics with statistical information in order to pick the best segmentation, which is a very common way to approach NLP as a whole. With that said, Japanese in particular does sometimes demand more creativity to solve certain challenges, but in general, you can see that what is intuitive to humans is a very involved and difficult problem for computers. In any case, that concludes my presentation. Thank you for listening. ありがとうございました。以上です。